Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre. With me is Z. Again, as many of you probably noticed, last week we didn't put out any episodes because I came down with something again. And so this episode is going to feature a few more topics than usual, as it's going to cover the topics we would have done last week as well as new ones. And it's a little bit unfortunate because last week was when Z started doing the prep streams, which some of you may have seen mentioned. And I think Z plans to continue doing them going forward and
Yeah, that's
get to see some of the insight into the background.
yeah, that's kind of the hope is to keep doing those and kind of give me a bit of motivation to get my notes done a little bit earlier instead of last minute right before the show.
Give me
And
an
at the
opportunity
very
to copy your
least,
notes. Yep.
but yeah, I finally did one of those and we don't even run the episode. So kind of got two back to back before doing one of these episodes. I said this on the bounty episode, but if you kind of have a time slot you'd like to see something like that in, just more convenient for you. I haven't settled on when I'll do besides probably doing it on either Friday or Saturday. Most likely not Sunday like the first one. That was just because I knew that week we were already going to be late, so I was okay with putting it off. But if anybody has some thoughts on that, feel free to message me on Discord if you have a strong opinion, or not necessarily too strong, but if you have an opinion, let me know. And, perhaps I'll play around with a few different time slots at least and see kind of what works and what, people can come around for. Because I do appreciate the chat interaction during that, asking some questions, because that can also then lead into questions that we'll try and tackle while we're actually on the podcast. And just having a chance to interact more with those of you that watch the streams.
Not even just questions, but even if you have some thoughts on a particular topic that you think like are interesting, it could give us a view that we could chat about that we might not have thought about otherwise. So,
Yeah.
yeah, it's a good opportunity to get like questions and thoughts in on the topics that we can cover on the podcast. So, yeah, check it out if you notice that Z is streaming, and the alerts for that will go out on all the usual platforms, Discord and Twitter and whatnot.
Well, I'm not
So,
sure if we'll keep putting them on Twitter. I don't want to just be spamming me streaming podcast prep
okay,
because
so
we
then the
don't
Discord
do
then.
podcast announcements on there anymore.
True. Yeah. So one of the things we were going to do last week was give a shout out to some of the talks that were given at CCC that we enjoyed. With all the time that we've had now, I've been able to get through a fair amount, and yeah, a lot of them I really enjoyed this year. We already talked about Operation Triangulation on the last binary episode. We actually talked about it for quite a while, so of course do check out that talk if you haven't already. But there were some other good ones too that I wanted to shout out. So there were two hardware hacking based ones. One of them was Nintendo Hacking 2023:2008. And that was a talk on glitching the DSI to get code execution in the boot ROM. And it had some interesting things with repairability there too, because apparently the DSI and I think the 3DS too had a very volatile like eMMC. It was very easy to break it. And because they had like per console signing and encryption and stuff on the firmware, if your eMMC broke, you were just screwed. The console was bricked. And this research enables you to like unbrick those consoles. So some cool stuff there. The DSI is a bit of an older console, but there wasn't a lot that came out for it as they cover in the talk. They go into developing a mod chip, so yeah, if you're into hardware hacking, there's stuff to enjoy there. Another hardware hacking talk that I really liked was recovering critical data from Tesla Autopilot using voltage glitching. This was a talk that was given by, I believe it was, at least some of them were the same people who had done the PSP platform security processor for AMD glitching. This was pretty similar in a lot of respects, but it was voltage glitching Tesla Autopilot, which switched from using AMD to using their own like secure boot flow. So they talk about like determining glitch parameters and stuff in there. There's some useful information on that. And they ultimately end up dumping data such as like log data and snapshots that are used by Tesla for correcting the auto driving. So there's also some fun reverse engineering stuff in there too, because there's some custom log formats and whatnot. And there's a little something of everything in there. More generally, I haven't completely finished this talk, and I also mentioned this in our bounty episode, but the talk writing secure software was a fun talk. The presenter was mocking the security industry a little bit with all these security solutions, but he mostly goes through a process he takes for developing secure software, and it's just an entertaining talk. It's not super low level or anything, but I did want to give it a mention. Another talk that I talked about on the bounty episode as well was Fuzz Everything Everywhere All at Once. The reason I talked about it there is they do talk about fuzzing for some higher level issues, which we haven't seen a ton of. But of course, where it's fuzzing, it is very relevant for like the kinds of stuff we cover on the binary episode too. They talk about libafl and combining that with QEMU and doing some snapshot fuzzing of Android libraries, as well as something that I wasn't really aware of, which is instrumentation at runtime through QEMU, which is where they can inject instrumentation on the lifted IR or immediate representation of the target to do some just-in-time instrumentation instead of having to do it at compile time, which, depending on your target, you may not really be able to do if it's closed source, and it's just a lot more flexible. And they also talk about catching some of the higher level issues as well at the same time, like trying to catch some injection based issues with writing sanitizers for SQL and XML injection and things like that. So you get the custom sanitization with coverage guidance. So there's some cool novel stuff that's being talked about there, stuff that could be applied in research at both the higher level targets and at the lower levels. So
Yeah, it does sound
to talk for
interesting.
everybody. Yeah.
Unfortunately, I haven't watched it. I kind of forgot to look at CCC stuff. So now that I'm being reminded, maybe I'll remember this week. But fortunately, I don't have any recommendations. Everything that I've seen is stuff that we were covering on the podcast, like the SMTP post or Operation Triangulation. But yeah, this everything one does sound pretty interesting after you brought it up on the bounty episode. But especially on the note of kind of fuzzing for some of the higher level issues where we don't have sanitizers are good ways to really detect they're happening right now. And that's kind of an issue with fuzzing some higher level applications is, it doesn't just nicely crash to let you know something happened.
Yeah, a lot of the stuff they were covering in the talk is trying to basically progress fuzzing from where it's been for a while, trying to solve some of the issues that have been plaguing it, like sanitizing for issues that haven't really been able to be detected before, but also addressing like scalability concerns, trying to make sure like things scale better and redesigning the communication with fuzzing. And yeah, it's just there's a lot of interesting stuff there. So I think a lot of the people who listen to the binary episodes would find it interesting.
Yeah, I'll probably
Um,
check it out.
yeah. One thing of note with the CCC talks, I would recommend checking them out on the CCC website that we have up here. They are also out on, or some of them are also out on the CCC YouTube channel, but they're drip feeding them. So they'll upload one like every couple days or whatever. I assume that's because they're trying to, play nice with the algorithm. Unfortunately, the YouTube algorithm punishes you badly if you do like bulk uploading. So yeah, if you want access to all the talks, you can get them on the site. Because some of them still aren't on the YouTube channel. So just wanted to give that a quick note. And yeah, that's pretty much everything I have to say with CCC. So with that aside, we can get into our topics here. So Z had noticed that Pwn2Own ran their first automotive competition, and I've seen a little bit of discussion around this. It's somewhat interesting because the payouts here are pretty wild. But
Yeah, like you said, definitely some big payouts on this one. It is interesting to see automotive. So it is automotive technologies. I think they have the one example here with the ChargePoint Home Flex, and then they have like a Sony infotainment system. And it's a variety of things, and a lot of them that I would kind of class not necessarily as IoT. Well, I guess I'd class them more as embedded, of course, being automotive. But the saying about IoT and the S in IoT means security. Yeah, there isn't a similar thing for embedded, but embedded often has a very similar feel when it comes to security.
I don't
It's
think I've
not
heard
there.
that one. Sorry. It's a good one. I like it.
Yeah, so there's that saying. I don't have one for embedded, but yeah, embedded is generally not seen as a very secure area. And I think that kind of comes out in the results from Pwn2Own here. Like, one, you see these massive payouts. Like, they are pretty big compared to what we've seen at some Pwn2Own, especially with the IoT. Pwn2Own was not this high of payouts. Let me actually bring up the results page. The day 3 results actually, I think, has the summary. Yeah, has this leaderboard here of everything where, like, St. Active got 50 points and walked away with $450,000. Even on the bottom end of the top 10, Team Clock, 5.75 points. I'm not sure how they got the partial points. I'm going to have to go double check the results for that. But still, like $41,000. And like some of the vulnerabilities don't sound like they're that intensive. Now, in fairness, like sometimes with Pwn2Own, the vulnerabilities just aren't all that crazy. It's just somewhere nobody was looking. I know some of the parallel bugs we've seen haven't been like that crazy bugs. They've just been somewhere nobody happened to look. And, whoever went and looked for it, found it, got a decent little payout from it. So it's not like all the bugs are always crazy, but still seeing things like a stack-based buffer overflow being what was exploited. In this case, this Midnight Blue and PHP Hooligans team executed a stack-based buffer overflow against the Sony XAV, basically this infotainment-like system for $20,000. Like, pretty solid payout for, presumably a relatively I mean, we don't know if it's straightforward, but a stack-based buffer overflow, and another team got a 20,000 payout for the same thing, but for a stack-based overflow, but on a different system. The payouts seem really high compared to what we've seen on others, and a lot of the bugs don't seem like, we don't have a lot of information on the bugs. Like, it's just like these little titles like use after free, stack
You can
based
infer, though, a fair amount,
well,
given
when I
like
see
context and whatnot.
yeah, when I see stack based overflow without anything else, that makes me think of just your traditional like overflow the stack, overwrite save return address, jump into your shellcode. Or maybe
And it
not
wouldn't
jump into your
surprise me if it was
shellcode,
that
maybe
simple.
raw too. But that's what I think of when I see that without any qualification, like no ASLR
Yeah.
break.
Yeah. And to be fair, like you had mentioned, areas that people aren't really looking at, and that's possibly why these seemingly lower hanging fruit bugs might exist. To be fair, with Automotive, there is a barrier of entry to be able to even start looking at
Mhm.
it, right? You need like specialized equipment, you need some of that expertise. It's not as easy as just like throwing a binary into a disassembler or running it locally. Like you do need some of that equipment, which is why I guess this event is fairly notable as well. Is it is promoting like auditing of Automotive more, which makes sense as it's becoming more and more prevalent. You're having like more of the self-driving technology and stuff. It is important that it gets audited. And I wish I remember who it was, but I'd seen someone on Twitter saying that they hoped that this event was sort of a wake-up call to some of these automotive industries that like, hey, you guys have problems. You need to work on the security front, because there were like a lot of successful pwns here, as indicated by what Z said with the payouts. Like Synactive walking away with $450,000. I mean, I think that's the most I've seen a single team take away from pwn to own in years. That's pretty wild. So yeah, I mean, we don't tend to cover pwn to own stuff as much as we used to on the podcast, because it started to get a little bit dry. Like Z said, we don't typically have a lot of technical information, but where this is the first automotive event, it is a bit noteworthy. And yeah, like it's not your bog standard IoT event that I've become kind of jaded with, where it's like, oh yeah, this TV was pwn and they got $10,000 for it. Like these are more interesting targets, and yeah, it'll be interesting to see if they continue running these events. I think they should. Like I said, I think automotive is a pretty important space to mature security on. So yeah, hopefully it
Yeah, but
continues.
it does have kind of those, like you said, barriers to entry. I did, while you're talking, just take a look at Team Clock to see what happened there with that 0.75. And turns out they actually lost 2.5 points because they withdrew an entry against automotive grade Linux. So they got a penalty of minus 2.5. And then they had a 4 bug chain to exploit this Phoenix Contact charexec 3100, and one of the bugs previously known. So that would be the 0.25 bit there, leading them into the how they got to 0.75 of a point. Yeah,
Interesting.
I don't think
I
I've
didn't even know there
noticed
was a
the,
withdraw penalty. I've never seen that before. But I
neither.
mean, it makes sense, but
Yeah, I don't think I've noticed it before either. And one thing that kind of stands out is Team Clock, for withdrawing there, got their 2.5 points taken away. But another team withdrew on like a EV charger and got 3 points taken away. Just interesting to see that 0.75 points, because usually maybe this is the first time they're even doing the partial points, because I do see like 0.2 or 0.5 points on a few of these.
I
Fuzzler
believe they've
IO
done
and
partial points before, but yeah,
okay,
like I
maybe I
said,
just
I
didn't
haven't paid
notice.
Like I said, I'm not 100% sure either because Pondo in the last like year or two, I haven't really paid a ton of attention to it, so I might be wrong, but
Yeah.
I believe that's been going on for a little bit.
Yeah, maybe. It's just kind of forget about it or just gloss over it. The 0.75 definitely stood out though.
Yeah. And as expected, going through the results, it seems there was a fair amount of bug collisions, which you will tend to see on like lower hanging fruit issues. We've covered some posts by people who have submitted to Pondome before, and they've kind of talked about how the meta of Pondome, like if you want to try to avoid the lottery issue, you have to look in the deeper areas that people don't want to look at. So, as these events run, the meta will probably shift more towards that as well. But on the other hand, like the chance of collisions is probably lower too because of what we've been talking about with the barrier to entry being higher with equipment needs and stuff like that. So yeah, I mean, if you have the means to do automotive testing, maybe like this Pondone event actually does look like it's pretty interesting and should be considered. But unfortunately, I don't think a ton of people have the means to look at automotive. So it'll be interesting to see how many teams continue to partake in that.
Yeah, it's definitely an interesting one. Like I'm a bit more excited about automotive than I am over like IoT that they launched a few years back or whatever.
It's got a lot, it feels like it has a lot more impact, something that has to be gotten right more. Yeah. All right, getting into our next topic, we have a bug with a simple root cause but a fairly substantial impact that basically completely negates ASLR as a mitigation on many Linux-based systems. So the title is ASLRn't. I appreciate that title. I appreciate the bit of the pun there. And yeah, so it completely negates it on 32-bit binaries and severely kneecaps it for 64-bit. You might say the mitigation was mitigated. And it's apparently been a bug that's impacted many Linux based distros with a 5.18 kernel or later for years, at least on certain file systems. Of course, the most common file systems ext4, ext2, Btrfs, XFS, and Fuse. And what happened here was after doing some testing, they noticed that 64-bit library ASLR had been weakened. In 64-bit, you should have 28 bits of entropy, which is fairly significant. As the common saying goes, like in 64-bit, you can't really brute force the ASLR or enumerate it typically. But what they ended up noticing was that instead of having 28 bits of entropy, it had 19. 9 bits were lost. The lowest 9 bits that should have been randomized were always 0. And what they later realized after they contacted the Ubuntu security team and found an existing tracking for their 32-bit regression was that these 9 bits of entropy were also lost for 32-bit, and where 32-bit only has like 8 bits of entropy or whatever, uh, that's all of them. And it was all due to the fact that in 5.18, this particular function, THP get unmapped, that's used in the drivers for file backed mapping, would use huge pages. Now, I won't go into all the specifics of paging in the Linux kernel, but typically your regular page size is 4 kilobytes. But there's also support for huge pages, which are 2 megabyte pages. The reasoning for this is to reduce like fragmentation, and it's a bit more performant when you have large things. And where files typically do contain a fair amount of data, like most files are over 2 megabytes in size, it would kind of make sense to use it in that context. Well, because of this, things like libc are going to be aligned to 2 megabyte page boundaries instead of 4 kilobytes, which loses you those bits of entropy on the address for the alignment. So it's kind of funny the root cause for this bug. And like I said, like the impact is fairly significant on the exploitation front. It's not an issue you could exploit directly or anything, but it would help you a lot in a lot of exploit cases. So yeah, very interesting scenario. Pretty surprising that it lasted that long without being like screamed about or anything. But yeah, I mean it's really just that simple of like the page size changing, and because of the page alignment, you just lose a bunch of ASLR entropy.
Yeah, on the
So
point of like it not being noticed for a little while, like 32-bit systems are just less common. And you're not necessarily looking at exactly how many bits of randomness you have on 64. You just see, oh, there's a fair bit and kind of gloss
you have to
over
do
that
some heuristics to notice it. It's kind of like those crypto issues where it looks fine at first glance. So like if you're looking at addresses and you're just like, oh yeah, that's not a fixed address. Most people aren't looking beyond that. They're not actually looking at addresses across runs and doing comparisons and stuff. That's fair.
Yeah, like it would be very obvious when you're sitting on a 32-bit system and it's just kind of broken there, but Yeah, like most people on a 64-bit, they're just not really looking at it. And yeah, I mean, that's why I could imagine just not having been noticed super quickly. That said, it's not like it took that long between like LTS and LTS, maybe what, a year or so from 518?
I actually
518
meant to
wasn't
look this up
a
before and I forgot.
okay. So I don't
um,
think 518 was like a long-term stable. I think the next LTS was
oh,
like six
518 was an
line.
LTS.
Oh, was
But it
it?
was, yeah,
Okay, my
it was
bad
released in
then. Then it might be
2022.
longer.
May of 2022 was when it was released. So
So yeah, a bit over
yeah,
a year and a half, whatever.
I actually thought it was older. I'm kind of like, with how fast Linux moves now, like
Yeah,
5.18 feels like a long time ago, but it wasn't that long. So
yeah, it definitely is. Like, feels like it's moving so much faster just because they're doing the number updates like every 3 weeks
yeah,
or 6 weeks or whatever it is. But yeah, I mean that's still like a year and a bit. Like it's a while, but it's not that long. In like this case, like we've had or I think we ended up not covering it this episode, but we were going to cover a bug that was like 35 years old. So that's
in
it's not
comparison to
long
that, yeah.
compared to that. But I mean, active development, things change. And this one, like, it makes sense on the developer side what they did, like using the huge page for the huge file. I mean, 2 MB is not what I would consider a huge file, but using it on a larger file
Well, you
makes
can
sense.
rationalize why this would have happened.
Yeah, and
And it's sort of an interesting case too, because it's one of those cases where it's a kernel change that's like creating a security issue on the userland side, which is not super common.
yeah, and all I was going to say on that though was like, the change makes sense and it's kind of easy to just not be thinking about bits of randomness. Like that isn't something that most developers, kernel or not, are really needing to think about. They just work with the options that they're given, and this is an option that's given.
Yeah, you have to look under the hood to actually spot it. So yeah, I love this issue because it's so simple, but it's it impacts a mitigation that is pretty much synonymous nowadays. So yeah,
Yeah, I love
it's
anything that hits the
got a cool factor.
mitigations. Like,
Hmm.
it's just kind of fun because it's a very security oriented bug.
Yeah, it's a good way of putting it. All right, so we've been talking about Linux for a while here, and we do have some Linux kernel issues that were reported to ZDI. These were in the SMB driver, or the kernel SMB daemon, and I'll let Z get into it.
Yeah, and not the most exciting bugs here. Starts off with a null pointer dereference, so very much not exciting. And that one just has to do with, and I'm not going to spend too much time here. Basically, it only checks if a session has been established on the first request coming in. So if the first request comes in, it doesn't need a session. The session field gets set to null. Another request comes in that does need on the same like socket, comes in, it does need a session. It'll just assume session was already set up and start using it. And of course, you end up where it acts as the session object, which is null, and you get a null deref. Not much more to say there. Then you get into a out of bounds read information disclosure, which kind of fun, and kind of they make a call out to the old Heartbleed attack, which was an SSL issue where you'd basically just give it a packet size, like an echo packet size. The size is larger than the actual packet, and so when it echoes it, it just overreads and returns extra data for it. In a similar way with the SMB write command comes in. The difference is it wasn't exactly the size, but kind of an assumed size. With this one, you would provide this value for the next command. So if you say like, hey, there's a command at this point, like whatever, or there's another command in the buffer at this point, like in the header, you'd say here's the next command location. You give that, and it would just assume that the current command must be from the starting of that buffer to wherever the next command is. And it would just assume, well, that is the size, and so it can eventually go to the next command and not actually validate that that size is like less than the actual size of the packet, or yeah, is within the packet. And so you could end up basically having it assume the length incorrectly, and you can end up getting an overread when it comes to the SMB write command. You can have it write too much into some specific file. And it's kind of fun that it does end up writing this into a file where it overreads the memory, writes into a file, which you can then call back out using the SMB read to read the dumped file. They also found that you could do a similar sort of thing with SMB echo. The difference there is that with the echo, they were really only able to get 2 bytes out of it, whereas with the read, they could get up to like 65,000, like the full 0x FFF. On echo, they can get 2 bytes. So unauthenticated memory leak, but only 2 bytes versus lots of bytes. But same, I believe it is the same core issue across both of them.
Yeah, I mean, what makes this post interesting and these vulnerabilities interesting is the remote aspect to it, right? Like you had said with the null dereference, like that's usually something we wouldn't even really cover, but where it can be remotely triggered,
We
it is
still
a little
don't
bit more
usually
interesting.
cover the remote null refs because it's just a denial service.
That's fair. But a remote out of bounds read information disclosure is fairly significant because we've talked about the fact before that like the biggest problem with RCE typically is getting information disclosure because you have to deal with things like ASLR and whatnot. Unless you're vulnerable to the last topic we covered. um, but yeah, like it is like a bit harder to get, so it is cool to see it here with the remote context. All right, speaking of more remote things, we also have PixieFail. These were 9 vulnerabilities detailed in Tianocore's EFI development Git 2, which is the open source reference implementation of UEFI, which, among all the crazy stuff it supports NetBoot for booting over the network for enterprise. And the official name for the specification for NetBoot is the pre-boot execution environment, sometimes called PixieBoot, which is where the Pixie in PixieFail comes from. As such, pretty much all the bugs here are bugs in the network stack, and really, they aren't super interesting beyond the fact that they exist. We are talking about EFI and network parsing here. The bugs are kind of what you would expect, such as like an integer overflow when parsing DHCP6 advertisement, IA, and TA options. They just take the option that can be attacker controlled from the message and subtract 12 from it and then perform a lookup with that value. That value can underflow to a large value and lead to an out of bounds read. Some other some other buffer overflows of similar nature. They also had a bug with using weak PRNG for protocol fields. They just seed it with like a time and a monotonic counter, which is fairly predictable. And they also use a linear congruential generator or LCG algorithm, which has been known and documented to not be a secure generator. So that can enable some things like DNS poisoning attacks and things like that, like any value that relies on randomness.
Does
So
it allow for that specifically? Do they call that out in here? Because I know they call
I
out the
believe they
weak
do, yeah.
random with TCP, but not. I don't know if they call it out UDP specifically, which would be for your DNS lookup.
Yeah, they
And
see the use of weak PRNG could facilitate DNS and DHCP poisoning
oh
attacks.
yeah, they do call it
Yeah.
right out there. I didn't. I kind of just scanned through this post because obviously there's so many bugs. I didn't notice that down there. Fair enough.
Yeah, they mentioned the per datagram unit incrementing. Yeah, so that makes sense. So, yeah, I mean, like I said, none of the vulnerabilities here is particularly interesting, but I did find it kind of fun because it's just one of those things that makes you continue to wonder why are we doing these networking things in the boot and EFI like this. I mean, I get that there is a use case for NetBoot, like when you're in an enterprise, there's some use case for that, but it makes you think that probably it should be designed a little bit differently because a network stack is a notorious bug farm, and that's not really something you want in the boot process where that's sort of getting to where your like root of trust is. But yeah, that's not how the industry sees it, and so there's a bunch of issues here. But yeah,
Yeah.
none of them are particularly complicated.
With the choices on like the random number generators, given the fact that it is so low level, they don't have a law room, like they don't have a source of access to like a good source of entropy to have like, a strong random number generator. Like I don't exactly fault them for it. Although when I see how they do the like TCP, so they call out the predictable TCP initial sequence numbers. If I recall correctly, like basically they had a fixed increment on it. So like sure, there'd be some randomness to it, but between two different sessions, if I trying to find it here. Yeah, use or it gets initialized to the fixed thing and then has the update with a fixed increment by the timer. So it's like using fixed increments from a fixed base. Therefore, you can do all the predictions based off of the TCP sequence. It's like I get why you don't have the strong random number generator for things that do need some randomness, but at least use it. Like, bring some of that in here, do something. Like, I don't know. It just seems like some of the implementations just seem rather bad or rather stupid.
Which kind of sucks considering this is the reference implementation. It's what people are going to use, generally speaking. So, in a reference implementation, you're hoping it's implemented with more, security in mind, I guess, and that doesn't really seem to be the case here.
Yeah, and I mean it's not surprising, honestly, given all the times we've seen that.
Yeah.
It's just like, yeah, I don't know. It just disappoints me.
I'm not angry. I'm just disappointed. Getting into a more interesting UEFI bug, we have a write-up on a bug that I was looking forward to seeing disclosed. It was kind of teased a little bit on Twitter, and then it finally dropped. And it was a Hypervisor Code Integrity or HVCI bypass on Windows due to configuration issue on certain Intel-based devices. So for those who don't know, we've talked about it a few times, but not a ton. It doesn't tend to come up a lot. HVCI is basically a virtualization-based security mitigation that tries to make it so that a compromised kernel can't violate the code integrity of the kernel. So they can't like edit existing kernel executable pages. They can't like make them writable to patch them, and they shouldn't be able to map new read write execute memory to be able to run shellcode in the kernel easily. At least that's the idea. The problem was when Satoshi Tanda and Andrea Aluvi actually tried and tested that assumption by dumping the extended page tables. On some devices from Intel 6th to 10th generation, they discovered that there were extended page table entries that were read write execute to the guest. And exploiting that was super trivial, especially because those guest physical addresses wouldn't change across reboots. You could just take one of those read write execute regions, place shellcode there, and jump to it. So very straightforward to exploit and very straightforward to find too. Like all they did was dump the extended page tables and notice like, hey, these are there. Where it gets a little bit more into the weeds, more of the technical detail is when they try to root cause this. And now, full warning, like this is going into some stuff that I'm not very familiar with, as ultimately what caused this is a configuration issue in the DMA remapping ACPI table, which is where these ranges come from, the reserved memory region reporting structure. They go into some of the background here, most of which I'll skip over as it's highly specific, and again, some of it is over my head. But what the issue is the fact that the BIOS should be reporting like any physical memory that's described in this reserved memory region reporting structure. And it should be reporting that as reserved memory in the UEFI memory map. When that doesn't happen, the secure kernel can't account for it, and so it doesn't end up like blacklisting that range when it's determined that HVCI is enabled. Because one of the complications they have to deal with here is the fact that early on in the boot process, when the secure kernel is running and everything, it's not immediately apparent if virtualization based security is enabled. So they don't know if they should be like changing the permissions on these ranges to enforce HVCI. So because those ranges are never reported, it just doesn't get the opportunity to do that. So it's sort of like understandable, just the fact that that region was missed. But I don't want to undersell the write up here. Like they go into a lot of the technical details of like VTX and VTD and the structures that are relevant here. And I really appreciate that. Like when you're getting into hypervisor stuff and these virtualization based security mitigations, there's not a lot of like solid information on them. So this write up is definitely worth checking out just for some of that background information if you are interested in that. But yeah, I mean, the vulnerability ultimately comes down to the fact that these read write execute mappings were there and they shouldn't have been. That's pretty much what you can sum it up as. So
Yeah, kind of has the simple summary there, but they do provide a fair amount of information that I found interesting, even though vulnerability, it's there. Like, that's the issue.
yeah.
But yeah, good information. Good
I
write up.
will say one of the unfortunate things with trying to like follow along with some of the deeper technical details, this low level when you're getting to the hypervisor and stuff, unfortunately does suffer from like TLA syndrome, where there's so many terms that if you are not aware of them, you're just like, huh? Like you just kind of glance through them, like DMAR and HPA, GPA, IOMMU, like root address translation, like all these things that you're gonna have to look up if you're not super familiar with them. And that's like that's just an unfortunate consequence of this area. But I think they do a good job nonetheless. They do provide some diagrams and stuff, and I found it followable, even though I'm not intimately familiar with UEFI and all the structures that they're talking about. So,
Yeah, same.
all right. So that's the main topics that we have for today. We do have some shout outs. A few of them are V8 based, which are getting a little bit specific. And this first one in particular is a little bit specific to V8 sandboxing. And I'll let Z get into them.
Yeah, a little bit specific to V8 Sandbox. I think you can kind of understand what they're going for here, but the main thing being that they're already starting from having a exploit running in the sandbox where they have arbitrary read and write inside of the V8 sandbox, and then using that to escape the sandbox through one of the WASM table objects. They're able to use that. And they kind of talk about how they're able to craft this primitive and what they need to do, a little bit of JavaScript integration there, and a little bit of their vulnerability being used to modify things. Then JavaScript kind of triggers it. Kind of just talking those details. I found it interesting because I'm interested less on like the sandbox scape. I mean, that's still important, but I'm also kind of interested just in understanding WASM's model or memory model, because I don't know, I can imagine a future where more and more applications are compiled into WebAssembly and are used like that. And WebAssembly has some interesting kind of aspects where you can still have memory corruption bugs. Like the languages that compile into it aren't all memory safe. But then what can you do with the memory corruption inside of WebAssembly? And it's a lot more limited. I think we covered one post that kind of went right into that, the calling convention and stuff a while back. But so I like seeing some of the details about how like these dispatch tables are being implemented, as that's part of what was exploited here. But it is, yeah, there isn't really a vulnerability here that you're going to see or copy to elsewhere unless you're doing V8. And then the second V8 bug here was just an Exodus bug, doing a out of bounds write code execution, Chrome V8, and this had to do with like the maglev is it optimizer lifter? What was that doing now? I forget. Either way, it gets pretty deep
I believe it's the JIT
into
compiler.
yeah,
Confirm
gets
that for
pretty
you.
deep into the Chrome stuff, well beyond what I'm going to be able to read up here. So I figured I'd just include it for those of you like the Chrome write-ups and are interested more on that side. Exodus generally has pretty solid write-ups, so this is another one of those, but it's a bit beyond me.
Yeah, so just to comment on that quickly, maglev is the mid-tier JIT compiler. So the top tier one, turbofan, is the one that's typically talked about. Like we talked about it a few times on the podcast. Maglev is like the level down from that. So that's why we're not as familiar with it.
Right, and then the third shout out want to bring up here, Voitsec. We've covered posts from them before, but they also did a course review of Offensive Securities Exploits 401. That is their advanced Windows exploitation. So the OSCE exam that you have to go in person and get in London or Black Hat or wherever they're doing it. Kind of has a review of it, including some of the contents, like what they're doing. VM workstation exploit, guess the host escape, some edge internals, which initially thought, okay, interesting that they're going for edge, but then when you think about it, edge had a lot of exploit mitigations and a lot of kind of bespoke things that they introduced, so kind of makes sense to still be doing some stuff there because their goal isn't really to be like, get you up to speed on browser exploitation, because the whole course is kind of covering quite a few different concepts, but it is getting you exposed to these different things. So fair enough. And they talk about like CFG, CET, so control flow guard, Intel CET control flow execution technology, I think, and ACG is their arbitrary code guard, just preventing you from. I think it's preventing you from making RWX pages, but I forget
What's that,
exactly.
sorry?
I believe ACG is just preventing you from creating RWX pages, like read, write, execute.
Oh,
I think
arbitrary
that's
code guard. Yeah, I believe
yeah,
so. Yeah,
yeah. I believe that's what that one's doing. Oh no, Windows has a bunch of mitigations, so they
and
talk
they
about
like reinventing terminology because when Microsoft, but
sometimes they do coin it. Like they were the first one. Other people kind of adopt something different, I think, too, or what, but whatever. Either way, they have a bunch, so I'm not sure if I'm remembering exactly the right one, but that sounds like the right thing for arbitrary code guard. RWX pages would be arbitrary code. Yeah, talking about that, Sandbox escape, Windows kernel internals, and a unsanitized user mode callback. So calling back from the kernel and do that. Getting another kernel exploit there where they again get like kernel, CFG, HVCI, virtualization based security, dealing with that, covering what the course does, thoughts on the instruction. Generally, just a lot of information about the course. Honestly, looks like a really solid review. Says a few things you'd probably be able to guess, like no, OSED is not enough to do OSE. Like there's a big gap between the two. Also mentions about employer perception on it, and it's been pretty, or it is pretty helpful in applying to vulnerability research and exploit development positions. Maybe also red teaming. Of course, if you go more fundamental, like just general IT or CS, people are going to care a lot less about it. But the noteworthy thing about OSE has always been that it has been a relatively modern training. Like they do keep it up to date every year and all of that. So it is, I think, generally speaking, it is like the most respected of any of the trainings that you could be doing on exploit development.
yeah, I
Um,
was gonna say I was looking through some of their scores for the days, and they seem pretty good. Like a lot of 5 out of 5s, 4 out of 5, like for their day content scores. And yeah, it seems like it's very reputed by VoidSec at least, and I've heard the same from other places. So
Yeah, and
matches
I'm
up.
not sure exactly where it is in here where they said it. Oh yeah, the astonishing amount of homework. That's the one thing I've really heard. Like they push a lot of content into this course, and so a lot of your time doing the training is actually outside of the training when it's over, doing all of the homework so you can keep up and like be ready for the next day. That's one of the main things I've heard from anybody that's done the course is, be prepared to be doing a lot of work outside of course hours. Just so they can get through all of the content. And they do mention like it is a fairly expensive course because it is in person. Guess at Black Hat, Middle East, and Asia, it was like 15,000 euro or pound. I
Damn, I
think
didn't
the
realize
little
it
E
was that
thing is,
much.
yeah, because I think it's still often like, even the 10K if you get it in Vegas at Black Hat. Although then you also have
Fair
to,
enough.
well, I guess you fight with bots regardless. But yeah, it's fairly expensive because it is a 5-day in person course. So it has that in person cost to it. And one nice thing is the same person here from VoidSec also, reviewed SAN 760. It's one of the other courses. They point out kind of one of the key things there is they're not the same. Like SAN 760 is kind of, in my mind, it is a bit more pen tester oriented because you do get things like, doing the patch diffing and going more for end day development. It also goes a little bit more broad and less like super modern, like talks just about buzzing and all of that. So they are different courses. He calls that out here, but it is a common question over like which one's better or whatever. Like they're different and they kind of have a different target. But yeah, it looks like a solid review. A lot of information just about the course because like you have a syllabus, but it is nice to kind of read the opinions from somebody who's actually gone through it and in this case gone through it fairly recently. So yeah, just want to at least shout out it's there. Take a look if you're interested in the training. Generally speaking, like I will say, when it comes to exploit development training, OSE is probably the most respected serve, but when it comes to getting hired or something, the bigger thing I think is actually having vulnerabilities and exploits that you have done on whatever target you're wanting to work on. and not so much having like nobody's out there being like you must have OSC. It's not like a requirement like OSCP is in some areas. There's none of that. It's good training if you can afford it, but and I haven't done it, but everything I've seen is it is good training if you can afford it. But like in exploit dev positions, like a main thing is just can you actually do it and can you demonstrate you can do the job or do the work. And then the last shout out that I'll jump onto here actually has two links and is dumping the ROM of a Game Boy Advance game by crashing it. This is just kind of a for fun thing because I thought it was really cool and kind of interesting to watch. So this first one is more just a proof of concept that they can take the crash sound and turn that into binary and actually try and reproduce the ROM. The second link which was a slightly earlier video from the same person where they talk about like the whole video has just several interesting observations they've noticed. And one that they document here is how does the Game Boy Advance crash sound work? And I thought it was really interesting. I know they're hiding details and glossing over things, but ultimately they end up talking about how the sound gets played. And the idea that they present, although they kind of indicate this may not be exactly accurate, it's just a high level perspective, is that you have the sound buffer that, you know, may get modified or whatever, but they'll push the pointer back and the sound card just kind of keeps playing linearly. You keep pushing the pointer back to the start of the sound buffer when it reaches the end, basically telling it like, okay, now start playing this, and repeatedly doing that. If you want to loop something, you can, you know, maybe not change it, but if you want to change it, you'll kind of put it in there and move the pointer back. So if the system crashes, the sound pointer or the sound card or whatever is going to keep reading, and that pointer is never going to get updated back to the sound buffer and will start reading all of the other memory in the ROM, allowing them to like dump the entire memory. There is a challenge when it comes to repeated bytes because usually the sound information will have some timing information coded with it. So when you have repeated bytes, it's losing that information. So you can't just figure out how many, you know, zeros there would be. And they kind of show the waveforms of it. And I don't believe they actually end up figuring that out. They just kind of match up with information they know. But still, I thought it was really cool and, you know, worth a watch. It's just kind of a fun thing. It's definitely not security related at all.
That's a fascinating like attack or whatever you want to call it, though. Uh,
Like there are easier ways to get their ROM off of the car, like off of the game card.
oh,
So
for sure, but it's
like,
a really like fun quirk to exploit. Yeah.
yeah. Yeah, I appreciate that somebody's going through the effort. And I actually just watched like the entire thing of observations there. I appreciate that somebody's just so interested in this that and they've done a ton of stuff when it comes to glitching these Pokemon games, it seems. It's just cool to see, you know, what people are really kind of investing in there and finding these random things.
Oh, especially with like Pokemon and stuff. If you go down the YouTube rabbit hole, there's quite a lot of interesting videos of like people reverse engineering and talking about like certain bugs and doing some root causing. There's a lot of fascinating people doing just research on the side into these older game devices. So if you have some time and you're looking for something to do, like that is a rabbit hole I would recommend jumping down. I've listened to quite a few interesting videos in that
Yeah,
area.
wasn't one of the Pokemon games recently like fully decompiled also, or am I mistaken? I know there have been some Mario games fully decompiled, but
I'm not sure.
yeah, fair enough. I think some have been like decompiled so you can actually like build them and, you know, get a accurate ROM or, you know, start modding it and stuff, but I'm not sure offhand here if it was actually a Pokemon game or not that I'm thinking of from recently. I'm pretty sure some of them have in general been done,
Yeah.
but yeah, either way, this one I just thought that was kind of neat and cool and just a fun thing to get or to do.
Yeah. All right. So that's all the topics we have for this episode. As always, thanks goes out to everyone who tuned in. You can join our community by joining the Discord and Twitter links that are in the description. Once again, Z is planning on doing the prep stream. So if that sounds like something that's interesting to you and you want to follow along with some of the prep work that goes into the podcast, the announcements for that will be on our Discord. So check that out. And with that said, we'll see you next week.